Hello guys, in this video I want to show you very interesting finding with your measurement model when you want to take a look at your Mahalanobis distance for getting rid of influential points and check how this affects your model. So in the previous video we established that this value, the original value, was a bit over 8, and I was able to reduce that value to below 5, which is based on this reference, so that we can accept the multivariate normality of the model, so we can use the maximum likelihood. Now I tried to reduce, to further delete some of my Mahalanobis distance. So now I'm gonna show you something here quite interesting. This is the data, the original data with, not original, but this is the data with only 10 points deleted. And I ran the model, and now I'm going to take a look. Of course, before we look at anything and everything here, before we look into the normality and whatnot, we need to double check that all these loadings are over 0.7, preferably. Or you can get away with 0.5, over 0.5, if you don't have a theory and you are putting the literature together. And over here I have all of them over 0.5. Now before I get into these readings, I need to double check the normality, the model fit. I'm afraid that maybe I said something very quickly and I said, oh, this is okay, it's significant. In fact, I just reviewed my notes. Oh, did I close my OneNotes already? So I just looked over my notes to make sure that I double check what I'm doing, and the chi-square here should be greater than 0.05, and it's actually not applicable for large sample sizes, anything over 200. So usually researchers won't even look at that, but it's good to report this. So over here, you can see that it is not significant. It is significant, and I want it to be over the significant level. In any case, it's not about what I want to be. I just wanted to show you different examples. This is the data as is without any cleaning of the Mahalanobis distance. Let's take a look and see how it is different from two levels of cleaning, or two iterations of cleaning. Over here, all the values above 0.5, nothing is below 0.5. And over here, taking a look at my model fit, you can see that it is insignificant. So this is a very good model fit for me. And however, this is not really taken into consideration for values for samples greater than 200. My sample is 225, but it's good to report something that is consistent with what is out there in the literature. And then over here I have very good measure. Let me just keep on checking here. After that, you need to look at your adjusted also. The absolute fit, you can look at the RMC, you can look at the GFI. GFI is over 0.9. RMC is below 0.08. So let's, and actually in some references, I think James Gaskin talk about 0.06 rather, below 0.06. So let's take a look at our RMC and GFI. Here's the GFI, very good, because GFI is greater than, GFI here is greater than 0.9. Now the RMC, we want it to be, hopefully it will be, the RMC here, it will be over 0, here is the RMC, it should be over, it should be less than 0. It should be less than, right? Yeah, less than 0.08, but in some references less than 0.06 even. So here you have less than 0.06 or 0.08. That's good. And this should be the P close. Do I have P close here? Let me take a look. They don't have P close here, but I think I have it somewhere. around and above 0.9, 0.9, higher, better fit, RMC 0. or less. I have other notes somewhere. Here, sometimes should be less than 0.06. Some researchers talk about that. And P-close. How about P-close? Do I have P-close anywhere here? I don't. Okay. I think P-close. Let me do the find. And see if I have it anywhere. I have P-close here. Only one finding here. What? Auto GFI? No. That's the kind of situations. Probably I was mistaken typing. I don't have it, right? But I think a high value is not bad. Now I'm gonna look into my notes again into that. But the GFI, P-close, sorry, higher than 0.8, I think, is good. Okay, so most importantly are these guys over here, over 0.95, good, very good. This is over 0.8, this is also good, and the adjusted is really good. And then we have all things nicely done. However, look at our assessment of normality. And this means notes for the model. We have 225 sample points. So we need to find this balance between getting rid of these values. So wait, so what I did is I got rid of these two, I think, the 50 and the 103. And now I'm going to show you the other file and run the analysis where I cleaned the data with some data points eliminated. And here we are. Of course, we need to take a look at the model fit. You can see that now I have it significant. It's not supposed to be significant, but it's okay because our variables, our variable summary, notes for the model here, we're still over 200. So we can just get away with not with that. It's okay. So yeah, I got rid of all the distances above 30, seems to be, and look what happened. I got below 5. So I am satisfied here because I also have all these values above 50. Look what happens when I go one step further, because I'm thinking I want to improve my results further. So I'm going to clean more. Do you see clean more? So I'm going to clean more. So over here, let's see what happens when I clean more data. So I get rid of the 30, I think. First thing first, look at the standardized estimates. I think one of them here fails me. Look, it is becoming less than 0.5. This is something that I don't want to see. And I'm not ready to get rid of follow. It's very important for my engagement. This is what the research is all about. So let's take a further look here. If it's really good for the multivariate normality, I'm probably gonna have to make a very difficult decision somehow. But before I go into all this, I'm gonna check again the model fit. Okay, on the edge, not bad. Okay, still nice, very nice. Okay, less than 0.6 and 0.8. Okay, very good. Over here about 0.8. It's over 0.5 or something. I forgot. I think my notes are corrupted somehow. I had that value there, but somehow it is letters instead. In any case, over here, okay, those are good. Now we are ready to read the normality. Oh, great! But I still haven't got to my to my 10 here, kurtosis. Anyway, it's less than 5. So what is it that I'm trying to do? And over here it was 4 point something, now it became 3 point something. I mean, this is getting reduced really slowly, and I don't feel that I am getting very high improvement here on the numbers, or I'm not supposed to, but in general I don't think that these values are highly influential either. So I'm gonna just stop here because I am losing my 0.5 a cutoff value. So I'm gonna decide now, based on my analysis, my iterations, to stop here for data cleaning. And this is what I was telling you all along. It's not just by a cutoff value. And over here I can see that this is 30, 29, 28, 20, there's no 27 here. So it's jumping from 28 to 26 immediately. Very difficult decisions. But it is in the vicinity. It is not a very distant measure here, far away from the rest. They are all clustering here, just a little spacing over here, but the remaining seems to be more. Let's plot that if you want to get more confirmation, just to make sure that I am not just trying to get the results that I want to get, because research is not all about that. But you also need to have your own human judgment. Okay, so let's plot this data. So insert and let's do the scatter plot. So this is the distance. So I probably would say over here there is a jump, I would say, but over here there's another jump. So this means I'm going to have to get rid of all these values, really, all these values, which may be all these values probably correspond to these. Problem with Excel, I cannot highlight certain values, not like with Tableau. It's a very difficult decision, really. If I get rid of these guys, they're not very influential in terms of probably giving me very fantastic results here in the assessment of normality. Also, I can see that some of the values here, I probably need to also monitor if some of the values here in the kurtosis and in the skewness are getting worse rather than getting better. You need to find this balance. And if you have the reference from the literature on this below below the 5.0, and you don't have that many points, that much of a jump here, 30, then you have 90, 29, 30, then 29, there's no jump, then 28, there's no jump. Then after 28, there's no 27, I can see that, there's no 27, but at the same time, 28.1 is almost 28, and 26.8 is almost 27, so it's not that of a jump really, do you see that? So I don't see that major jumps like how we've seen earlier in the Mahalanobis distance being 50 and then down to 40 and then down to 38. Yeah, so I don't see that much of a jump, and to my assessment this would be an acceptable result, and I will keep this as is with only cleaning 10 points that are almost about 5% of the data set that exhibit an influential or can be considered as influential data points. Now let me just run the analysis. I think I ran the analysis with you last video, and I have seen that probably it will be fun anyway to run the analysis again. This is the cleaning more. This is with less data. I would like to run the analysis again to take a look at the reliability. If anything really major happens with the reliability, in particular, I would like to see that in the correlation of item, total item correlation, correlated total item correlation. Over here, I'm going to get rid of the negative here. I'm going to get rid of the not trusted over here. And there is the second one. But the second one, we got rid of it after the readings, yeah? So let's here, do we need to check anything in particular? No. So let's hit OK. What happened? Check something. Okay, I forgot to check the above two. Now we are fine. Okay, so let's take a look over here. This is the correlated items. I can see that still it is below 2, so I will still have to delete it. So even with cleaning more data, it has improved from 0.17 something to 0.18, so not a very huge improvement. So probably, yeah, it's not worth deleting more data. It's not improving any reliability here. Cleaning the data is not improving any reliability. Cleaning the data, more and more data points, is not really superly influential on this normality assessment at all. And for me, I'm gonna just stop here. To say the truth, guys, I in fact use bootstrapping anyway, because I was a little bit concerned about the multivariate check. I see multiple researchers referring to critical value 1.96, even though it's very difficult to attain with big samples, but I see them reporting having multivariate here, critical value for multivariate model being 1.96, and I was also curious about learning how to do the bootstrapping. So bootstrapping is usually used when bootstrapping usually used when you don't have you have problems with the normality check. Also, I would like to see the VIF, guys. Let's check the VIF if it got improved with the cleaning of the data. This makes the decision even more and more difficult. So let's take a look. If it got improved, you might have to make some difficult decisions, maybe to get rid of the data because your model fit is okay, but then at the same time, you're gonna have to decide which item you want to keep, because do you want to delete the VIF of here follow for this one, because the VIF is no good for the follow, or you want to get rid of follow over here for engagement, which is the major goal of our study. So also one more thing is to try to take a look at what you can do for the VIF. Let's take a look at the VIF again. This is the data clean more, and we're going to put this here. And for statistics, we're going to ask for collinearity, guys. And for plots, we're going to ask for, or maybe we don't need the histogram for now. Let's just keep running the analysis. And over here, you're going to get the VIFs. So VIFs are still above 3. So, well, then I'd rather stop there and just get rid of the, as we discussed in the previous video, get rid of one of these guys. And maybe this table has some problems, in fact. Probably the data is not plugged in correctly. So I'm just gonna then decide that where I have a very good standing here, and I'm just gonna, based on these results of the regression, linearity, and multicollinearity, as you can see, guys, I'm just gonna get rid of, you see there are two items here that has 3. One item is CI likes, the other is the CI number follow. So I'm gonna just get rid of C2 follow, and this is how we want to, this is what we do with the results. Okay, and then report that in your paper. I'm going to report that also. I'm going to put VIF before or VIF here after elimination. I like to report everything. So VIF after elimination. So this is a next check point. So it's not an easy judgment when to stop with your influential outliers cleaning. You need to find a very good fit between meeting the assumptions and also keeping a nice data set, as well as making sure that reliability checks and that correlated item total correlation is also being reviewed again.